An application is often required to make database access, perform file read and write, or contact internet for communication. All these tasks involve time-consuming operations that make the main thread too busy. This causes the application to hang and freeze while the main thread waits for a large file to download. The solution to this problem lies in asynchronous task programming. A potentially long and time-consuming operation can be run in parallel in such a way that the user interface remains responsive and possibly provides a feedback to the user. Let's explore this in this tutorial. A function intended to run asynchronously should be marked as async modifier, and it should return a task if the return type is void and task T if it returns a data of type T. For example, a function that makes an internet communication or disk access or database communication is marked as async, and it returns a task or task T depending on the type of data returned. Task string if it returns a string type, task int if it returns an int type. Create a C# console application for the latest version of .NET Core. Open the Solution Explorer and add a class called myClass. And then add a function called async task int myFunction. It has been marked with the modifier async, and it returns an int wrapped in a task. Both async and task, they signal that this function is intended to run in asynchronous mode. Come to the program.cs file and create an instance of the class myClass. Print a message that announces that we are about to start an asynchronous task. Make a call to myFunction and obtain the task object. This will start the execution of myFunction. The moment you call myFunction, the execution will start and you can store the task object in your variable. And now let's come back to myFunction and add a message that this function has started its execution. And next we have some variable is created and a loop is started. Remember that the execution is still synchronous. So far it is synchronous only. Next, let's add an artificial delay of 5 seconds. Await task.delay 5000 milliseconds. In a real scenario, this delay is caused by some disk access, database access, or by network, or by some image processing function, anything. The await keyword tells the compiler to suspend execution of the currently executing function. myFunction, it is suspended at this point, and let's see what happens here. Firstly, your compiler uses a CPU trick to return back to the program.cs file. Secondly, a new thread is not created. Multi-threading doesn't occur here. It is just an optimal use of the free CPU time. And thirdly, the calling thread is not paused here. Nothing stops. The control is returned back to the program.cs file while the 5-second period is counted. myFunction continues to run optimally through the CPU, and program.cs file will start its execution at the point where we entered here. There is no multi-threading, it is just a CPU trick done by C# compiler. That's all I can say at the moment, but details you can study at your own level as you grow. Come back to the program.cs file and print a message now that we are back. Notice that we have numbered the messages in an expected sequence. Later we can verify that the numbering appears in the expected way. So now while the previous code is counting its 5 seconds, we are free to execute our program.cs file in parallel. Let's say we start a loop here. Once the loop is finished, we can print another message that looping is finished now. We also print the message that program.cs is now waiting for myFunction to send its return data. Program.cs file has done its task, Its work is over now. It is now waiting on the return from my function, which is counting 5 seconds there. Everything is in parallel. Program.cs file now pauses its own execution by using the await keyword on the task object. This task object was obtained in the beginning from cmc.my function. The same task object now, we are awaiting on that to finish. Now while the program.cs file is waiting, let us come back to my function. Let's add a message that 5 seconds have expired and the task is finished. The long running process is over, artificial delay has done it, and now we are printing a message. The return statement now returns I. The compiler will automatically wrap this I in a task, and this function is now over. Let us now come back to the program.cs file. We can now add the variable y of the program.cs file to the data obtained from a long running function, and the console write line now prints the combined result. So this is the whole point. This is the whole point of asynchronous programming. We calculated y, and we also started a parallel calculation of data from a long running task. We made an optimal use of the CPU. The main thread was able to make calculations of y by running its own loop, and then it obtained the data from a long running task, added them, and displayed them. Run the project now. We verify that all the messages appear in the same order as we expected them to.